5, 4, 3, 2, 1. We have booster ignition and liftoff. Liftoff of Discovery, and the shuttle has cleared the tower.
It takes a tremendous amount of thrust to lift the space shuttle off its launch pad. Have you ever wondered what's in the fuel that propels the space shuttle into outer space? Well, the answer to the question is aluminum. Aluminum powder, derived from alumina, the starting stock for molten aluminum, is the key element in powering the shuttle into orbit. Aluminum in a fine powder form make for a very strong explosion when the right conditions are present. These conditions, fuel, oxygen, and an ignition source, are right at the moment of liftoff for the space shuttle. Unfortunately, those conditions can also be right here at Warwick Operations. The video you're about to see will introduce you to the finishing to ingot scrap conveyor, or the F.I.S.C system. But first, you need to know about the potential dangers of aluminum dust. Aluminum fines are present in the scalper chips and the edge trim scrap returned to ingot from fabrication by the F.I.S.C system for remelting. The conveying equipment that moves the scrap from finishing to ingot also tend to make finer particles out of bigger pieces. You must always keep in mind that these fines, if in a high enough concentration, have the potential to explode. Fuel in the form of aluminum fines and oxygen are always present. All it takes is an ignition source to produce an explosion. Dust clouds from aluminum fines are the thing we worry most about. Alcoa has in place the equipment and the procedures to greatly reduce the chance of an explosion. Employees have a role to play in helping to prevent explosions. The best way to avoid a dust cloud is to prevent dust accumulation by keeping all work areas clean. You must always follow the safe job procedures for the work you are performing. When engaged in any maintenance activities in this area, be sure you strictly comply with any special work permits and other instructions. Remember, cleaning, welding, cutting, or any other activities that has the potential of bringing together the 3 explosive ingredients must be done in accordance with the procedures and the practices as noted in the Hot Work System Manual. When equipment is installed or changed, make sure the design and operational guidelines according to the Alcoa engineering standard are followed. Know the location of wetter agents and use them properly. There are fire extinguishers, telephones, and intercoms throughout the system. Know where they are before you do any work. Finally, if an aluminum dust fire does occur, vacate the area immediately and phone 4333 for fire department response. Do not attempt to fight an aluminum dust fire. It is a potentially explosive situation.
These people in finishing are putting the final touches on a coil of metal to prep it to our customer's specifications. The edges of this coil are trimmed to the customer's specified width. The scrap from this process must be returned to ingot for remelting. This reduces waste, much as in recycling. Every day, a huge amount of edge scrap has to be moved all the way from finishing to ingot for remelting. How is this done? The chips are returned to ingot using blowers through a conveyor that makes up the F.I.S.C system. That is the finishing to ingot scrap conveyor system. Starting here at the prep line, when choppers underneath the line cut side trim into small chips. The aluminum chips are moved by vacuum to cyclones on the roof and fed into the conveyor. Then the chips are blown through the conveyor from finishing to ingot by 14 blowers in the F.I.S.C system. Basically, the F.I.S.C system is a wind tunnel for conveying scrap aluminum chips from finishing back to the silo at Ingot, where the chips drop in for remelting. Jams of aluminum chips sometimes occur in the conveyors. When this happens, sensors located inside the conveyor automatically divert the chips to tubs. At this time, lights located at the control panel will turn on to show the conveyor section where the jam has occurred. From a safety standpoint, the thing we are most concerned about in the F.I.S.C system is the danger of aluminum dust. Dust from aluminum chips can form a powdery substance called fines. In a high enough concentration, aluminum dust can explode, just like dust in a grain elevator. For that reason, it is extremely important to keep the work area clear of aluminum dust buildup. Wear proper protective gear for the work you are doing, and follow safe job procedures. This concludes the introduction to the F.I.S.C system. Other videos in this series will concentrate on safe job procedures for particular jobs in your occupation. When performing welding, cutting, drilling, or grinding on or near the F.I.S.C system, it is extremely important to remember that the F.I.S.C system is a potentially explosive area. Suspended fines are especially dangerous. Fuel, oxygen, and ignition are the three ingredients necessary to create an explosion. Two of these three ingredients are already present in the F.I.S.C system: fuel in the form of aluminum fines, and oxygen. All it takes is an ignition source to create an explosion. For this reason, you must be especially careful to follow safe job procedures when performing any welding, cutting, drilling, or grinding repairs on or near the F.I.S.C system. Any of these repair jobs can bring together the three elements necessary to create an explosion. Refer to the Hot Work System Manual in every maintenance office for cutting, drilling, welding, and grinding. Follow all requirements for obtaining a hot work permit. Take the permit and survey the job. Clean up all trash, paper, oily rags, etc. from the area where you're working. In working on the F.I.S.C system, plant protection personnel must approve the hot work permit. If excessive chips or fines are present, place a 4x8 sheet of plywood under the area where you are working. Cover the area within a 10-foot radius with a fire blanket. You must cover the conveyor vents with fire blankets if minor repairs are being performed in or near the vicinity of the F.I.S.C system when the blowers are running. If excessive fines are present, you must also have available at the job site a 5-gallon can of wetter water. The wetter water agent can be obtained from the mechanical maintenance crib in Building 260. In areas where excessive fines are present, you must use air-operated or non-sparking tools, such as air-operated drill motors, air-operated saws, and beryllium tools. This completes our review of safe job procedures for welding, cutting, drilling, and grinding repairs on the F.I.S.C system. Remember, it is essential to follow safe job procedures. The F.I.S.C system is a potentially explosive area.